Welcome everyone. So, as Irina mentioned, today's session is how to set up an AML data labeling pipeline, best practices and examples. And before we start, let me just tell you a bit more about myself. So I work as a data evangelist at Toloka, and my background is in AI. This is what I have studied at Edinburgh University. And then I worked for several years in different roles connected to data science. I've been also involved in teaching and mentoring data scientists, and I contribute to Medium publications such as Towards Data Science, so you can find me there as well. And I would like to tell you just a bit more about Toloka. Toloka is a crowdsourcing data labeling platform that can be used to quickly label large amounts of data. And we will talk about Toloka a bit more in the context of data labeling during this presentation as well. So let's have a look at the agenda for today. So at the beginning, we will spend some time talking about different challenges connected to data. Then we will explore a bit more what crowdsourcing is and how it can help us with both challenges. Then I will give you some tips how to set up a data labeling pipeline. I will give you some best practices and some examples. At the end, we will talk about the automation of the whole process. And as Irina mentioned, at the end, I will take time to answer some questions. So feel free to write in the question tab if you have any. Yeah, let's get started. And so let's start with some challenges that we have with data. And as you can see, this is an old graph that has been published in Forbes a few years ago. And what is important to note here is that 80% of the time of the data scientist is spent on preparing and managing data. Even though this graph has been published a while ago, I think this is still true. You can see here an exact distribution where the work is spent, but I don't think it's important for this presentation. I think the most important here is the fact that 80% of the time it's a big amount, and ideally we would have some tools that would help us to reduce this time. Another problem with data is can be connected to the fact that modern AI products are kind of built on three pillars, and those are like algorithms, hardware, and data. And actually, the first two already have pretty good solutions that have been proposed, and that they've been explored quite a lot in the last decade. So like algorithms, we have really good libraries such as TensorFlow, PyTorch, maybe scikit-learn here as well. Hardware already as well has been explored a lot. We really have good storages and computing power of data, and it's available pretty much to everyday user. However, the data part has not been explored so much, and we don't really have any well-known tools in this area. And it's currently becoming a bottleneck for many AI products. Probably many of you know Kaggle, and maybe some of you even competed in Kaggle events, as this is a very popular website for data scientists. And I just would like to mention here that once you compete there, you compete within a given data set. But this is actually not what happens in the real world, because in the real world, you not only compete within the data set, but you actually compete with the whole machine learning pipeline. So basically, people who can manage this machine learning pipeline and manage the data better would win in this case. Talking about this, I would like to show you the machine learning pipeline probably many of you are familiar with this kind of pipeline. Maybe it's a simplified version, but normally we train our algorithms, then we spend some time validating those. Once they are good, we push them into production. And if they deviate, somehow we retrain our algorithms, and kind of this cycle continues. However, what many people do not realize is that a lot of, all of those steps require human labeling. And this is not just a few human labels. Actually, it's a human labeling on the large scale. So I want to show you a bit revised pipeline here. It's exactly the same pipeline you have seen before, but I have added a human icon at each step just to represent a human involvement in each of those steps. So in order to train our algorithms, we need data labeled by humans. The same is at the validation step. And again, the same is also in production. In order to know if our algorithms are performing well on the real life data, we need someone to actually judge it, and that would be human. If we want to retrain our algorithms, again, we need a human labeled data. So we already know that we need a lot of data, but I would like to point out some requirements for the data labeling process. And those usually are, we want our data to be of good quality. So basically, we don't want to feed rubbish to our algorithms. We would like probably to our process to be within some budget, so the price would be important as well. We ideally the process would be scalable and accessible. So in case that we have to label some additional data suddenly, we should be able to do it as well. And we would like the process to be pretty fast, so we don't want to wait weeks or maybe months for our data to come. And so talking about the problems, but now I would like to talk about more about the solution that could help us with the problems we just seen before. And crowdsourcing is one of the solutions that could be proposed to solve this data labeling problem. And what is crowdsourcing? So it's basically breaking complex problems into smaller tasks and distributing them across the crowd. So on this image here, you can see that we have a big task, and it's broken down into smaller pieces. We have a cloud of performers who are able to complete those tasks. And then we have some kind of form of aggregation to have our final problem result. And how crowdsourcing could be used in machine learning. So I just wanted to point out here that it's not only data labeling, but it could be actually used for many steps. It could be used for data gathering. So you could actually ask people, for example, if you want to train a computer vision algorithm to recognize faces, you can ask people to basically take selfies and gather them. The traditional kind of thing, and this is the point we will be talking about, is data labeling. But the crowdsourcing could be used also for model evaluation. So imagine that you already have some model, it's working, and you have created a new one. You could actually ask the crowd which version of the model is better. So it could be used for some A/B testing as well. We could also use crowdsourcing as a human in the loop concept. So this would be the case, for example, if our algorithms is not so sure about the prediction, and we could actually use a human labeler to help the algorithm to take the decision. Another way we could use crowdsourcing is performance monitoring. So this is when we already have our model in production and we want to monitor if it's deviating, and we could use crowdsourcing for it as well. And Toloka platform is a crowdsourcing platform, and this is just a very simplified image how it works. So on the right-hand side, we have requesters. So that would be probably you guys, data scientists, machine learning engineers, researchers. And those requesters, they post the tasks that are stored in Toloka, which is the platform. And those tasks are distributed to the crowd, which is on the left-hand side. In our case, we called our crowd Tolokers. So this is the image how Toloka works. And I just wanted to point out some advantages of crowdsourcing in the data labeling sense. And as we mentioned before, we would like our process to be fast, scalable, cost-effective, and have a good quality. So the first three are pretty much guaranteed by the fact that we use the crowd. So usually, if you have large crowd, the process should be fast, it's easy, scalable, and because you can choose the price you pay, it could be cost-effective. But what is not guaranteed by default is if your data will have good quality. And this is why we actually need the crowdsourcing platforms such as Toloka, where we can set up and develop the quality control tools that are needed for crowdsourcing. And another important aspect of crowdsourcing in a sense of data labeling is that we ideally would like the process to be fully automated in our machine learning pipeline. And this could be achieved by having some kind of API or SDK embedded in the crowdsourcing platform. And actually, about this, I'm gonna talk a bit more at the end of the presentation. So let's start with the core of our talk today. So how to build a data labeling pipeline with some examples and best practices. So in our experience, we usually break the data labeling pipeline into those 6 steps that you can see here on this slide. The first step is the composition of the task. So usually the task needs to be broken into smaller pieces. The second step is writing clear instructions and designing interfaces. Then we have to focus on selecting and training performers. After this, we should focus on quality controls. Also, we should focus on choosing the price. At the end, we should aggregate the results. And we will talk a bit more in details about each step of those of this pipeline in the following slides. So let's start with the first one, decomposing a task. And I would like to give you a short example here. Imagine that you are training a computer vision algorithm and you would like your algorithm to detect traffic lights. So basically what you need to do is you need to gather a lot of labeled traffic photos with labeled traffic lights with bounding boxes. So what you probably would do with Toloka is you would just create a project, or with crowdsourcing, you would create a project and you would ask people to label, to draw the bounding boxes. Seems very simple, but actually, if you do not decompose this task well, you could actually run into some problems. So for example, if you just have one project like this, outline traffic lines that you see on the picture, what would you do with pictures that have no traffic lights? So if you give those pictures to people to label, basically you are wasting money, because if there are no traffic lights, they still have to focus the network on finding them, but there is nothing to be labeled. And another problem here is, how do you know if the bounding boxes they have drawn are correct? So in order to kind of mitigate those problems, the ideal solution that we have experimented with is having actually, in this case, 3 projects. And this is probably something that would be common for this type of computer vision projects. So instead of having one project, we have 3. And in the first one, we take all the pictures that exist and we ask a performer to label if a photo contains a traffic light. We only send pictures that contain traffic lights to a second project where we ask to actually do a labeling of the bounding boxes. The results of the second project are then flow to a third project where we ask different people to actually mark if the bounding boxes are correct. If these people say those are correct, we accept the responses from project 2. If the results from project 3 are basically people are saying that those are incorrect, we could reject the responses from project 2. So this is an example when a task that looks pretty simple can be broken into 3 different tasks. And another thing that we have to focus on when we design such tasks is writing clear instructions and designing good interfaces. And I would like to start here with some very basic tips regarding instructions. So they should be short and concise. Usually we say they should fit on one page. They should illustrate examples and they should cover some edge cases. And it's a good idea to use some text formatting or tables and lists to focus the attention of the user on specific things. And let me give you an example of some good and bad instructions regarding the project that we have discussed before, the bounding boxes with traffic lights. And here on the right-hand side, you can see example of bad instructions, and on the left-hand side, you can see an example of pretty good instructions. So why the right-hand side is bad? For example, it says to the performer that assignments that are labeled incorrectly will be not accepted. But there is no examples what means bad and what means good. On the other hand, on the left-hand side, we see clearly one example of correctly labeled traffic lights and an example of incorrectly labeled traffic lights. So I think it's pretty easy to spot that the left-hand side is much better. You would be actually surprised how many people actually use something similar to the right-hand side, and then the quality of the data can suffer. And another important part is designing interfaces. And usually our performers would take our task either on some kind of computer, tablet, or maybe a mobile device. So they will be interacting with our task with a browser. So the interface usually is set up using HTML, JavaScript, CSS, something like this. This screenshot is taken from Toloka. We have an alternative to HTML, JS, and CSS, which is called Template Builder. You can see an example of Template Builder set up here. Is basically a JSON style format with some predefined JSON containers that you could use to build interfaces. And regarding the tips with the interfaces, you should always focus on the fact that if your interface will be used on different platforms, you actually should design it to be cross-platform. Also, if you know that people will be taking it using computers, it's a good idea to add some shortcuts. So in the example here, you can see that in order to choose cat or dog on the picture, a user can use 1 or 2 shortcuts on their keyboards. It's also a good idea to check if the required actions have been completed. So if somehow your data labeling requires that something was played, you should check if this video was played. If you need someone to select buttons, you should check this as well if some of them were selected. I think maybe it's not needed to say, but you always should check if your interface, all elements work. It's good idea usually to complete a task by yourself. That way you ensure that all elements can work. And just another tip is that if it's possible, you should avoid navigation to external sites. So that would also depend maybe on your task, but if it's not needed, it's better avoided. And the next section that I would like to talk about is selecting and training performance. So the crowd and crowdsourcing and the crowd basically give you access to many people around the world, and they are available almost all the time. But what happens is they speak different languages, they come from different cultures, and you actually should focus on selecting good performers for your project. This is actually a picture of the crowd that we have at Toloka, and just my suggestion here is that you should always think about filtering people maybe by country if you need, by language, also by some computed properties such as what browser they are using or what region their IP address is showing. And last but not least, you could filter them by some skills that they possess. And I would like to give you maybe an example of such filtering. This is an example using Toloka. So here we are just choosing people who speak French, and additionally, they have passed a specific French test, or they speak English. We do not require a test to be passed here. And we only take people that use tablets, and we choose only people that have been born before a certain date. So you should basically adjust those filters according to the needs of your project. And another important aspect regarding performance is you should not only filter them, but you should actually train them. So the idea is that you should always write really good instructions which illustrate the examples well, but you could also prepare some training tasks for your performers where you allow them to make mistakes, but you provide some corrections so they actually learn how to do your task well. You could prepare such trainings and then maybe provide a test where people could be assigned a skill based on the test results and be allowed on your project only if they achieve a certain level on the test. So besides focusing on your performance, there is you should strongly focus on some quality control rules. So let me tell you a bit about those. We're gonna start with some very basic quality control rules, where we call them behavior checks. And those are the ones that should basically filter either really bad performers or bots that could appear in crowdsourcing platforms. And the way to prevent those to spoil your data, you could use catchers. Again, maybe you should not use them too frequently, not to annoy people, but maybe every 10 tasks or maybe every 100 tasks, you could add some. You could use some speed control checks. So basically, if the task should take maybe 20 seconds to complete because someone has to look at the picture, think about it, and decide, and if someone is basically doing all your tasks under 1 second, probably they are not paying attention. They might even not be reading your task. So it's a good idea to disable them access to your project. And you should also check for required actions if they have been completed. we talked about this one a bit already in the interface. So if there has been a video that was required to be seen, you should check if it was done. So these are just basic checks. And let me give you an example of something checking those basic components in Toloka. So this is an example of fast responses. Basically, what are you doing here? If someone has already completed 10 different tasks, and if he completed 5 of them under 10 seconds, you ban them on your project for a day. So again, you should adjust those according to your project needs. And this is just an example that to show you. There could be some more sophisticated quality control checks that you could perform. Those are not only to filter very bad performers and bots, they could also basically filter bad performers that are not doing, maybe they are not clicking randomly on the task, but they just maybe did not get instructions and they just consistently doing the tasks badly. And one way is using control tasks, and another one is using overlap. And let me tell you a bit more about control tasks. So control tasks would be tasks that are created by you, and they are the same as normal tasks, but the difference is that you already know the answer to those. So basically, by having control tasks distributed among normal tasks, you could compute how well performers are doing by checking the number of control tasks that has been completed correctly. And then again, the problem becomes how to create control tasks. So they could be created in a variety of ways. Sometimes you have to create them manually. So basically you have to sit down and maybe mark a percentage of your data. It could be maybe 5%, 10%, depending on your needs. They actually could be created using a crowdsourcing platform where you would be very certain of your results. So for example, you could use very big overlap. For example, you could ask 10 people to do the same task. Or sometimes they can be generated. This is maybe a rare case in some machine learning problems where basically automatically we have some examples of control tasks. And what is very important regarding control tasks, those are some tips. They should always be the same as true tasks. So performers should not be able to distinguish them from normal tasks. They should be up to date. So in case you have a project that is taking an ongoing project, maybe you need to update them on weekly or monthly basis. Again, depends on the project needs. They should be big enough. So again, if you have if you send 1,000 examples to be marked up, and if you have only two control tasks, that would probably will not be enough to have an effective way of computing skills for a performance. So they should be big enough. And the distribution of control tasks should be similar to this distribution of your data. So if you, for example, are recognizing cats and dogs, probably you want to upload the same amount of control tasks involving cats and dogs here. And let me give you here an example of using control tasks in Toloka. So here again, we take 10 last responses into considerations. And if someone already have completed 4 tasks for us, we check how many of those tasks were correct. And if his accuracy falls below 75%, we ban him on the project for some time. So this is a way of using control tasks for disabling access to performance who are doing incorrectly are labeling our data. And another thing that is important here is that usually one task is not sent to one person. It usually sent to several people. So this is because we do not trust one single person. We rather would send it to several users and then check for consistency between those people. This is something we call majority votes, and I have provided an example here. This is again screenshot from Toloka. We set an overlap to 3, so the 3 people will be performing the same task. We accept majority as 2 people out of those 3. And if somehow the responses of a person disagree with the responses of other people more than 25%, we would ban him on the project again. So this is again to give you an example of a setup. Another important part of data building the pipeline is deciding on the price. And this is something that a lot of people ask when deciding, when trying to build data labeling pipeline. And there's actually not an easy answer here. And the answer probably is it depends on the project. So I prepared some questions here that you should ask yourself when deciding on the price. You should first check how long it takes to complete the task. So again, something should not be priced the same. If it takes 10 seconds, it should not be priced the same as something that takes maybe half a minute. What you should also think what skills are required to perform the task you are asking. So again, something like recognizing cats and dogs, anybody could do. But maybe if you require some specific knowledge, you should also consider paying more for such tasks. You should also think who your performers are and maybe focus on the geographical distribution. If you maybe require people to live in some specific country or speak a specific language, again, you should adjust the price accordingly. Another tip here is if you want to decide on the price, you should do the task yourself, time how long it takes you, and that should help you to judge how long you should pay for it. Once you already launch a task, you could also monitor interest. And if you see that there is not enough interest, you could maybe consider increasing the price that you offer for a specific task. And there is another tip here that I would like to share here. And we have experimented with performance-based payment, so-called dynamic pricing, and we had really positive results. This is a very good way to motivate the performers. And the idea behind it is that normally you would pay maybe $1 for completing a task. But if someone is really good at completing your tasks, you should pay them more. So in this case, normal, just everybody is paid $1. But if they are scoring very well on our control tasks, so like, for example, they did 6 of them well out of 10, they should get a 30 cents more on this one. If they've done 7 control tasks out of 10, well, they should have an increase of 35. And actually, if they are doing everything perfectly, they should even have a bigger bonus. In order for this to work, you should actually inform the performers that there is this kind of dynamic prices, and if they mark your data better, they will be paid more. They should know about it. And another important thing when deciding on the price, we always want to automate the process, but we should not forget that behind those are real people. So this is just to add this important note here. The last step of the pipeline is actually gathering the results and aggregating those. So as I mentioned before, usually your task is not sent to one person, but to several people. So there could be different ways of aggregating those together. The most basic aggregation technique is a majority vote. You already saw this with some quality control rules. Here it's not used for quality control, but for aggregation, but the idea is the same. So here you have an example of a picture, and a person has to decide if it's cat or dog. And we can see that two people have said it's a cat. One person said it's a dog. Well, so the majority thinks it's a cat. We actually think our label is a cat. But actually, this is not always the best way. And I wanted to show you the example when the majority votes can actually give you bad results. So imagine that you have used some control tasks and you know what are the abilities of your performers. If you have this knowledge, it's usually better to take a weighted majority vote. So we're gonna go back to the example we had before. Remember, two people said that something is a cat. And if we only take the majority vote without weights, the label would be a cat. But what happens here is our performers have different abilities. And the third ability, the third performer actually has a higher ability than the first two. And even though he was the only person who said that the label is a dog, if you compute the weighted majority vote, the label should be a dog and not a cat, as the normal majority vote have suggested. So this is just an alternative you could use if you know abilities of your performers. There is another aggregation algorithm that has been used. It's called David's Kane algorithm. And this algorithm is good when you do not know the abilities. You don't have a control task, so you don't really know what are the abilities of your performers. And we're not going to discuss here the details how the algorithm works, but the idea behind this, the fact that the data should speak for itself. So if the data that fits best should be considered the correct one. So in this case, you can see that there is the last two, the second and the third person had the same answers. So we know that the likelihood that those answers are correct is higher than the first performer who gave answers that are very different from those two. So basically, the idea behind this is that if someone puts random answers, they are very unlikely to coincide with another person's answers. So this is how the David scheme algorithm works, and how you could aggregate the data as well if you don't know the abilities of the performers, and you don't want to use normal majority votes. And so I just would like to recap here those 6 points of our data labeling pipeline. So we started with the decomposition, we then focused on instruction, then we talked about designing interfaces, and then again we mentioned how to control quality and how to decide on pricing. And also we talked about how to gather and aggregate the results. There is one additional step here which has not been mentioned. It's the project maintenance. So ideally you would use this pipeline constantly, so you need to maintain it. And this is why we should actually work towards the full automation of this process. And I wanted to show you again here the machine learning pipeline with a human label at every step. So ideally, normally the training, validation, retraining, and monitoring is done using code. A lot of data scientists probably work with Python, maybe with some Java and different programming languages. So ideally, you would set up your machine learning pipeline using code as well. So this could be done again using some kind of API or SDK. This would allow you to treat the crowd as another computing cluster. And this is what we have been trying to do with Toloka. And that's why we provide a Toloka kit. This is a Python library that you can install in your either Jupyter notebook or your production environment. And then you can just import the Toloka client and interact with it. So you could basically set up the project, do quality control rules, filter performance using Python code. So this is a very useful tool that leads to this full automation that we would like in machine learning. There's another library that we've created. It's not directly connected with Toloka. It's a library for aggregation, and this basically involves all different aggregation techniques that we have been talking about. It could be used with any crowdsourcing library to aggregate the results. And what is another thing that is very important in data labeling pipeline, it should integrate easily with other machine learning tools. So they are nowadays machine learning engineers, data scientists use a lot of tools to orchestrate, monitor algorithms, and we've been experimenting with the integration of Toloka. We have currently provided some tutorials how to integrate it with Pachyderm, Airflow, and Prefect. And I'm pretty sure we will be working more on this type of integrations that that would involve putting our data labeling pipeline into full machine learning process. And yeah, this is the end of today's talk. So I would like to quickly summarize what we have been talking about. And we started with talking about data and the problems connected with the data. And we have mentioned that it seems that data is current bottleneck for many AI products nowadays. We then talked a bit more about crowdsourcing and how crowdsourcing can help with this data labeling problem. Then we talked about 6 different components of building data labeling pipeline, and I shared with you some examples and some best practices in these areas. And at the end, we also talk a bit about integration of this data labeling process in machine learning lifecycle. And if you like this presentation and you want to learn more about crowdsourcing, I would really encourage you to check our crowdsourcing course on Coursera. And if you like this presentation, I would also encourage you to try Toloka. We actually have provided for you a promo code. It's called Toloka 2022. When you use it, it will load some free credit on your account that you could try Toloka. If you will have any questions how to use it, and you would want to also learn more about crowdsourcing and data labeling, you can also join our community. You have a QR code here, and I think my colleague will send now some links to those in the chat as well. And yeah.